So we're going to get started, and let's see if Samsudin, I think he's the only one who joins back. Okay, if he joins, that's fine. Otherwise, we'll get started. Yeah. So we have an hour and a half today, and I was hoping that if we can go into this exercise and complete it. The question number 8, we tried to train last time. Did you guys manage to run afterwards, or any progress made? I managed to rerun few bits just now before coming here. So I spent a last hour around 245 minutes on it. The last bit with the dropout, it errored somewhere. So we'll see if we can fix during that time around. This is the one which I think, but I was fixing it myself, like a few things. So we will look into it. So shall we get started? All good?
Yeah, sure, good.
Okay, so perhaps like just a little quick walkthrough on last time we did a couple of questions. Sorry about the scrolling. Okay, so that's on the top. So what we are doing here is practice training on a deep neural network. So we have a CI-FAR image data set, and we're gonna train it, and then we go from question A to F, where he is asking us to do step-by-step changes. So the model doesn't change quite a lot, but interestingly, when you train it, you'll learn bits and pieces here and there. So we did a couple of things last time. So I'm going to go again back. He asked us to build a deep neural network with 20 layers, and each layer having 100 neurons. And that's what we are doing here. We created a model through a sequential model. Our input image is 32 by 32, 3 channels. So this is colored image, and we added 20 layers of 100 neurons. So the activation, we are using a LU, and the initialization is Haw normalization. So that's what we are going to use. We have 10 classes in the end. So we're going to use a softmax in the end to get the class. That's what we have. He tried different learning rate, and he came up with the 5 e⁵ is the best learning rate. So we're going to use that. And loss function is going to be sparse categorical cross entropy. And as we discussed last time, when you have more than one class, more than 2 classes, we use this categorical function. And we're looking at the accuracy as in a matrix in the end. Through Keras, we have, this is the database. This is the data, CIFR 10 data. We loaded into xtrain full and xtest. Xtrain full has, I think, 60,000 images. 60,000 images of 32 by 32. So we're going to divide first. So first 5,000 are going into validation set, and the rest is going into the training set. Few bits we're going to do is we're going to early stop our model. It's going to go to 20 epoch to see if the validation is increasing from a point. If you keep on increasing, or if there is no change, it's going to stop. And that model will get saved like my CI-FAR 10 model. And then it's going to spit out the logs into directories, this directory, and those logs will get used into the TensorBoard, which we're going to look. Okay. And yeah, TensorBoard we store here. So we have checkpoint callback stored here, TensorBoard callback stored here, log directory. It's a callback or it's a log directory which get passed into TensorBoard here. And what was it? TensorBoard, model checkpoint, and early step point. Okay, 1, 2, and 3 callbacks, they get listed in here, and which we in turn pass into our model. And these are the 2 commands, magic commands, to show the TensorBoard. So I went ahead and for 100 epoch, I ran that initial model. It went up to 56 epochs, and it gave us the accuracy of 46 on the test set, and I think, yeah, 46 on the validation as well, 46.4670. I think he was getting around 47. I'm getting 46, 7. It's almost same. So what? Just a quick question: have you tried? Any of you tried this, and have you got any better, or what's accuracy? Anybody?
I didn't finish it last time. I'll run it now and see.
Okay, and that's what I want as well. We have I think hour and a half, so we can quickly run through them. I think it won't take the whole lot. Maybe in the end we may struggle, but if you want to give it a go now, it's perfectly fine. We can take like 10 minutes to run and then 10 then to discuss and so on. So when we are talking, you can go ahead and kick it off. Same for you, Maria.
Yeah, I think,
so,
well, I still have what I got from the last time on my screen. And that one has like 0.57.
On the first without any.
Yeah, I think so.
Oh, lucky you.
Although I didn't do anything different, so I don't know.
Because the 5.7 is the step B. Are you getting on a step B, or?
I'm not sure, maybe.
Maybe because it start increasing when we start adding the I think normalization, or the batch normalization. It improves quite a lot on a batch normalization.
Okay. Yeah,
the only thing which for the question number B for me was he got the on a 39 epochs. Oh, maybe so. Oh, so here I was saying 56, but 56 minus 20 because it's going into 20, and that means 36, around 36. And he's saying 36. We are getting a good accuracy. Yeah. 468, 469. Okay, we got in here 53. 469, 469. Yeah. Okay. My question was in terms of, like, he was saying he got this accuracy on 39 epochs, and I was actually looking at here. However, because this is where my training stopped, so I guess I need to go 20 steps back to see if he's saying like it's improved. And interestingly, after 36, it improved a bit, but it decided not to run another 20 after, let's say, 46.9. Where is that? Here. So I should have gone 42 plus 20, 62. I didn't go 22 all the way. I went just, I think 53, 56, and he stopped. You know what I mean? Yeah, so it's, but it because it was, I think, decreasing afterwards, like the 16 epoch, so I decided to stop. Yeah, so I was confused, like why I'm going all the way to 56 while he's saying 39. But it makes sense. And that's if I come up here, so this is nice. Like every run is listed here, so I can just pick first two because that's what he is naming them. So this is the accuracy of a training. Orange is training, and this is going up, and then I guess it's here start kind of like getting saturated. And same down here. If we look here, training is going down, but here around here it start getting saturated, so it's not improving whatsoever. So that's the first run. Any question or anything you guys like to discuss about it?
The training keeps going till.
Sorry, you got mute all of a sudden.
Oh, sorry. The epochs keep training with respect to validation loss, right? Not validation accuracy. Is that right?
I think both. Yeah, validation loss. Yeah. So we said we are saying here early stopping. So we're saying keep going for 20 epochs and stop. Yes, it's the validation loss is gonna look. Yeah. Okay. Gautam, you wanna complete this run or you wanna move on to the next one?
What do you mean?
I mean, like, are you running this or shall we move on to the next?
Yeah, we can move on. We can move on. Yeah, sure.
Okay. So in the next question, all he did was he asked us to add a batch now and see what difference it's going to make. So we still have the activation between the layer LU. The activation on the last layer is softmax. Loss, we still have the same. Everything is same. All he asks us is nothing but just to add a batch normalization. And he goes like, okay, just run it and see what difference it makes. So basically the first one takes around 5 minutes. Second one takes quite a long. It takes around 20 minutes to run, 15 to 20 minutes. And it kind of finished, he says, a bit early, but for me it's the same. The first one last was, if you see here, 56 epoch. It finished around 50 first epoch, so like kind of 5 epochs before, you can say. So if the first one, let's say if we step back 20 from 56, around 36, 35, it reached the saturation point. In here is reaching on a 31. So not a huge amount of a difference. However, for him, it's taking, like he said, 18 epochs, which didn't come out for me. So I was curious to see. I ran it twice, and both time I never received this 18 epochs. 18 plus 20, let's say 38 epochs. I never received this. Let's have a look into the validation accuracy or validation loss. We can look either of them. Validation accuracy, validation loss. So let's say we went in loss 33, 32, 32, 30, and then it's started increasing, and 29, 31, 30, 34, 32, 29, 47. This is still down, which is on epoch 31. I'm gonna go up and see if I get anything like this 1.29 up above. Obviously not. So in a sense, the least, it started getting around 31 epoch, even 1.29. And if I go down below, yeah. So at the best, on a 31st epoch, I got the lowest validation loss, not on the 18th. So I was curious to see if you guys get the same results or not. Obviously, I think based on probably, okay, so this is the question. Why would, because we have a same data set, same model, what difference we have now, which for me, it's taking 51 epochs, or let's say 31 epoch, and then here for him is taking 18 plus 20, 38. So there is a huge difference, like I think difference of 13 epochs. You know what I'm asking?
Sorry, can you say that again, please?
So random, I'm saying he claims that he got the accuracy, the lowest validation on 18th epoch, okay, and I got the lowest on 31st epoch. That's my lowest here, this guy, yeah. So
okay.
in a sense, there is a difference of like a 13 epoch or my validation and his. So I'm just thinking the model is same, the data is same, well, the seed is same, except I'm like, I can just think of this only, the kernel initializer, because these are the random numbers.
Yeah, even those should be the same once you have set the seed.
Exactly.
Yeah. So what could be the difference between the two of us, because everything is same.
Yeah, even I've never been able to reproduce results most of the time. Even if I set like 10 or 15 seeds, things always change. I don't know why. It always happens, yeah.
But it makes sense that your results would change slightly with different initializations, but if you set seed, you should get the same initialization, right?
Yeah. Is it could it be some hardware stuff, like the seed for a certain hardware is different from another hardware? I don't know.
Yeah, it's possible actually, because I remember when we were doing Fast AI, even when we set seed, our batch was different to what we got on if we ran the same code on a different day. But a colleague of mine who was running the same code on the same day as me got the same batch as I did. So unless like they're, do you know what I mean? Like, I don't know how you would, I don't know what that means. Yeah, I don't know. But even then, I would not expect such a big difference if just with initialization.
Yeah. Okay, so let's move on. So what he's claiming in here is that you get you converge quite early. However, you get I think you get the accuracy. Last time we got 47%, and now he got the 55%. I think I got the I got the 55% accuracy as well. Yeah. So that's about right. But the speed, the batch norm affect training speed, although the model converts twice as fast, each epoch took 16 seconds instead of a 10 second. Actually, mine takes quite a lot, like 25 seconds each epoch. So obviously hardware difference is there. But yeah, the overall, your batch normalization give you more accuracy, but it's the training computation time goes up. And if I show you this guy here, so let's go, that's the batch normalization here. If I can even let's say, if we just validation and validation. Okay, maybe if I can maximize, and it's better for you guys. It's not that clean. I'm not sure how to get rid of this guy. But anyway, so this is the what's it's telling us. So I think this is the accuracy epoch loss when we have batch normalization, and when we don't, this is the how do we interpret it? So validation loss with batch. Oh no, okay, yeah, sorry. This validation loss is without batch normalization. This with the batch normalization. So it start low and then it keep decreasing. So yeah, so there is a difference. You know what I mean? So I'm like the batch normalization has, even when we started the loss, it started from a lower number. So loss is gonna go down from very beginning at least. That makes huge difference. So we jumped from here to here automatically, here to here automatically with the batch now. Make sense?
Can you compare the training losses of with and without batch now?
Yeah. Training and training. Yeah. So
which one is the one with batch now?
This is with the batch now train loss BN. If you see the colors up in the, if you look at up the color, the circles, it says run underscore BN underscore 001. So that's this one, the dark color.
Okay.
Dark color. Yeah.
Okay. So batch norm is not regularizing, right? So if it was regularizing, it would have brought the training loss down and the valid loss. Sorry. Yeah, it would have affected the training loss but made the valid loss better. But in this case, both are doing better.
Better. Yeah.
Yeah. So it's, yeah. Okay.
So what do you mean by not? I think it's, well, I'm not sure what term to use. However,
Because
it has given us jump down to this point automatically.
no, because if you see what dropout does, dropout like increases your training loss but lowers your validation loss, because that's the price you will pay to for generalization. But in this case, both the training loss and valid loss get lower.
Yeah.
So yeah, it's just helping the model train in a better way. Yeah.
Better. Correct.
Yeah.
Yeah. Okay.
In a faster, easier way. Yeah.
Is it a faster, easier way? Yeah. So there is no, I know what you're saying. Like there is no term which we can put into place. But however, it start with the lower loss, and then it's gonna converge faster. I would say, and that's what the point he's trying to make was like, you don't need to travel quite a lot to get there. You need to travel less because your loss will start from lower point and then you keep on reducing. Okay, so that was that. So that was second question. C is adding batch now, which we did. Now, third part he wants us to do is nothing but just try replacing batch normalization with the CELU and make a necessary adjustment to ensure the network self-normalize. That is, standardize the input feature using Licon. Okay, so that was C, which we have already seen. D. So instead of the LU, we're going to use the CELU. And then I think he is using the optimizer as Nadam. And I think learning rate, again, he tried different learning rates, and this is the best he came up with. Yeah, and that's pretty much, oh, so this is what he's saying. I think we discussed last time. For CELU to use, you need to normalize the the input, and that's what we are doing in here. So And that's pretty much it. And that's what he's saying, self-normalize. I ran this, and so we got the accuracy gone a little down from 55.
What's X valid scaled?
It's scaling up. It's scaling the it's dividing,
Okay.
subtracting the mean and divided by.
Okay. Yeah. Okay. But the same as the training. Yeah, that makes sense.
Yeah. So yeah, so we got this 0.51, and that's, I think it was 34. So obviously, it what we say, converge easy. Like last time I was getting 51, but now it's like on a 34. So if I look at the loss is quite low here, and then if I go up, let's say, yeah, 46, 45 here on 14th, 43 on the third epoch, validation loss. Oh, well.
You're looking at accuracy there, Dinesh.
Sorry. Looking at it wrong. So that's the validation loss. 1.795451 49 here. 4948 1.73. Yeah, start increasing. Yeah, so that's what the best. I think on epoch 16 I'm getting this. And it took him, like for me it's a 16, for him it's 13. However, the accuracy reduced a bit from 55 to 51.
So last time, sorry, we did not standardize the images, right? Before inputting it to the model?
No, we didn't.
Okay. Isn't that like recommended that you should standardize the input anyway before feeding it to the neural net?
Neural net, yes, I think it is. However, yeah, well, I'm not sure. For a Celio, I think last time we said it required it. For LU, I don't know. But in general, you're right. This is what they say, that all the features need to be standardized, which he has done in here. Yeah, we didn't do in the case up here.
But we added a batch normalization layer just after, no, even higher, even just after flatten. So that has, I think that has a very similar impact.
Yeah.
Okay.
So that's this. The effect of this is kind of similar to this. Is that correct?
Yeah, I think so.
Yeah.
Okay, so let's go up. I have run this as well. So this is your Celio, and if I just add this guy here, okay, so it starts somewhere similar to the loss, but it went down for a training quite early, and then it gave us, like, rather than going to 55 or 60 epoch on 35 epoch, like it stopped. Obviously around 16 epoch we got the best accuracy. So if I just go and then run the Celio here, yeah, so the training loss keep going down here, around here, and then start going up from here. So this is the optimal result we are getting for the Celio. And same hold for the accuracy if we go just up here. Anyway, so anything you guys want to discuss with this? Shall we move on to the next one?
Yeah.
Okay.
Sorry.
So now he's saying try regularize the model with the alpha dropout. So this is where the dropout comes into a picture. Okay. So all he wants to do is he taken out the batch normalization and just added a alpha dropout layer in here, and Yeah, so in alpha dropout, because we don't have a batch normalization, he is doing that in here, standardizing the inputs. So one question I have is, oh, we're using Nadam and Cellu. That's why. So if we go from, let's say, LU and Adam here, we could have added a batch normalization in here. That's my guess. Anyway, so we should run it. I think I ran it, but I'm not sure if I have a result. So maybe this is a good idea. All of us can run. I don't have a result here. Or maybe one more time if I just do enter. Let's see if I have. No, actually I have results. So do you guys want to run this question number E? Maybe take a time, 10 minutes to run this E to C and present tensor board in front of you.
Yeah.
You don't need to go from a top, because what he's doing is he's building the whole model here. So you can just quickly start from top and then come back to top. I think if I show you this guy, I can paste this. So you need this definitely. And chat. Just take these guys up there, and I think you should be good to go. And for the tensor board, one extra command in place of this, just push this guy and it's going to come, and that's it. And let's run the question number. Dropout is E, and let's come back in 10 minutes to discuss it. All right.
Sorry, when did you say we were coming back?
In 10 minutes.
Okay.
Let's run it 10 minutes. You may be in the middle, but let's see if it finish early or not. I know we'll have a discussion. Yeah. So because I think there are only two. There is another question left afterwards. So we have two different kind of dropouts to discuss. So it's a good idea to run this on our laptop, and then we can come back and then have a discussion. Let me put the alarm on.
Have either of you tried running it in Colab? I'm just trying to understand like where it saves if we.
So
I don't know. I mean, yeah.
it might saves. What does it do is it creates a directory, subdirectory within your working directory. So I think if you go on a Colab, then it's gonna create a subdirectory, temporary directory.
Sure.
Yeah. Okay.
Do you guys know what alpha dropout is?
No.
I was looking at it. I thought maybe alpha dropout is a dropout.
The regular dropout?
Maybe I'm not sure. I was before coming to this session. I was looking at the chapter. He hasn't mentioned alpha dropout. He has mentioned MC dropout. So I thought maybe alpha dropout is something similar to a dropout. Answer to your question, I don't know.
Yeah, okay. It's there in the TensorFlow docs.
Okay, maybe. Yes. That keeps me. Okay. Stop sharing. Stop sharing. You guys good? Managed to run it?
Yeah.
Okay. Let's see. What did you get? So I think my accuracy didn't go up. It's a 51%, which was with previously when we did the batch normalization with the Celio. It's the same. And epochs 29. Yeah, I'm like that's quick, bit quick. You get the same something similar?
No. Oh, maybe.
Yeah. Okay. Let's see the TensorBoard. What TensorBoard is saying. TensorBoard is quite handy. Okay. And what's going on? Ooh. Something ruined for me. I got 3 lines, so I'm not sure what's going on here.
No, it's bizarre.
Yeah. I'm not sure what's going on here. for a gray as well. Are you getting the same graph?
No, I don't think so.
Okay.
Mm.
Oh, I know what's going on here. I think what I have done is, I think I know for the next question. I was getting error. So I just copy pasted the previous code. And I think it's, and then I didn't change this guy. I didn't change, I think one part I didn't change where I should have here. So what I did was for the next question, this guy wasn't working for me. So I said, okay, I'm just gonna copy paste and add the layer MC alpha, but I should have changed the model here, this guy, or a log directory. One of them, oh, this guy should have changed MC. Yeah. So that's why I think I have muddled up a few things there. Okay.
Yeah, but that suggests that it's not completely overwriting files, but it's like adding it to the end or something.
Yeah, so it's I think it, so the code says it's the directory is same, and it's going to create the I think another with the name, with this name, because the name was same. Now if we look back in here, I think it will tell us that's the directory, and that was a subdirectory. And in here, when we go training, so I think in here it got mixed up. So you may have a 2. So I think now it's picking up all of them together, 3 of them, I guess. So you probably have maybe 1 or 2 if it's V2, E2. So this is what's happening, I think. Yeah. The validation is saying, yeah, 2 of them. You may have just a 1 over there. So that's the issue. Anyway, so we go back here. Is that the one? Yeah. So we did the alpha dropout. Yeah. So Gautam, you were asking questions. So this is what he's saying. Alpha dropout is a dropout that keeps mean and variance of input to their original value in order to ensure that self-normalizing property even after this dropout. Alpha dropout fits well to scaled exponential linear unit by random setting activation to the negative saturation value. I'm not sure what is that. Original value.
Yeah, maybe instead of setting them to 0, they are just made big negative numbers, I think, in order to maintain the mean and variance. Not sure.
Yeah. Variance of input to their original values. Sort of, yes, sort of like the normalizing as we keep on doing, not to have too much fluctuation when we do a dropout. I don't know. It's there anyway. That was the one thing. And let's move on to the next one if you have no question. Okay, so let's move on to the next one, which is this guy. Oh, no, this one. Try regularizing the model E. So we are on E. Try regularizing the model with alpha dropout, which we have done. Then without retraining the model, see if you can achieve better accuracy using MC dropout. Without retraining your model. So I was not supposed to train it. So what he was what he has done here is the MC alpha dropout, as last week we were discussing, that once you have done the dropout during a training, generally you don't use it, dropout during the inference. However, the Monte Carlo alpha dropout, you will use the dropout. You will use the dropout, but what you do is you take a combination. I think you take a number of predictions and then you take an average of the predictions. And that's the concept of MCA Monte Carlo dropout. If you remember, I was looking at the here, which is nicely defined. Basically, if I go in here, and I think in here just 1 second, somewhere it's the probabilities. So, not this one. Where I was looking, I think this is the one he's saying, the mean of the probability. So you have sample, you have taken sample of 100, so you're getting 100 probabilities, and then you're getting a mean of those probabilities. So when you use a Monte Carlo dropout, so I think for the same test, for the same test input, you're gonna use it for 100 times. So sample, I'm not sure what the sample would mean. How would it get a sample from one test set? So maybe this is a bunch of test sample, and then you keep the random sample 100 times, and then get the probability on it, and then get a mean on it. That's what I can think of. So that's your MC dropout. So what he was asking here is, he created a class MC dropout, which is inherited from an alpha dropout, and we, in the call function, we just call the parent class. So that's the MC alpha dropout class defined here. And I think if I go down below here, he has two utility functions defined, where now I'm not sure what the n samples are he's going to use, but let's keep going. So this function is defined where he take a model, and then he take an input, and how many samples he's going to take, and then he loop through it using the model and predict those values for those samples, number of samples, and he creates the mean of those probabilities. So that's your MC dropout predict probability is going to return, and whatever probability comes in, we are going to find out the class out of it. So we will push the X into here to get the all the probabilities, or sorry, the average probabilities, and for that probability we're going to get the class. So he's using a function within a function. Okay, so let's see how he is using. I was getting error. So when you define a model up here, so I'm not going to do it. So let's say do this, and when I try to, now what he has done here is he replaced the model. He replaced MC alpha dropout in place of alpha dropout. So that's what he was doing here. And down below, after this, just ignore this guy here, because that's I copy pasted. And here, all he did was like start using that model, MC model, for a prediction. And when I try to use it, it gave me error. So that's where it starts saying unknown graph, and I didn't have any clue. What does it mean? You guys want to try what whether you going to get the same or different?
Sure.
Yeah, try it, please. And that's where I said, okay, maybe I need to build a model from scratch.
So why did you try to recreate the model again?
Because what he was trying to do is he just replaced the the
Dropout
layer.
layers.
Yeah, so just drop out layer and he start predicting it. So start using for a predict. So he didn't train a model. However, when I try to do it, I got this error. It says unknown graph. So I was not sure. I thought maybe once you have the alpha, once you have this MC, sorry about the scrolling. Let me go up. So I thought when you create a dropout, you need to train a model again. So that's why I said, okay, I'm gonna start trying to retrain with this.
Since dropout does not have trainable parameters, that's why he has just replaced it. It does not have any weights, right?
Yeah.
So you can just replace it and it would still work well. So you don't have to, yeah.
After training. So you're saying, oh, so you're saying you can train a model with the one type of dropout, and then you can replace it, and then you can use for inference with the other kind of a dropout.
Yeah, yeah.
Okay, I get it.
Since
But
nothing gets trained in the dropout layer, I think you can do that.
That's clever. No.
There are no weights in the dropout layer.
Yeah, I get it. I understand what you're saying. Yeah. So like this part, let's say, just ignore this part for the time being, because I thought I need to train, but it didn't work. So something wrong in here, which I need to figure it out. So I'm curious
I
if
think
you're
it
getting.
worked for me. Yeah.
Yeah.
It worked for me.
It worked for you.
Yeah.
I'm not sure why I keep on getting this. Yeah, for me, it happened last time. I think this was the model we trained. Oops. Okay, not MC. Okay, I'm gonna just skip this part. I'll go back and then try to run it again. If it works for you, should work. So I may have made a mistake somewhere, and maybe because I updated it a few times, so I probably have made some mistakes somewhere. Okay, if it worked for you, then it's fine. Did you get any better accuracy? He is.
No, it's the same, I think. 5.50. Yeah.
So no difference whatsoever with the.
But each epoch only takes, well, it was only like 15 epochs, but also each epoch only took like 2 or 3 seconds, I think.
Okay, so that gives us good.
Yeah.
Shouldn't it be
Same
much slower since you are doing it many times?
Yeah. But I have 2 seconds and it didn't take very long to do any of them.
But you're doing the evaluation.
Right. Yeah. I mean, yeah. If you compare just the evaluation for MC dropout and normal dropout, MC dropout should be slower. Yeah. Evaluation in general is much faster than training, of course. But yeah, if you compare the inference speeds, they should be slower.
But where did you get the epochs for evaluation? Does it run number of epochs for evaluation?
Yeah, it should not. Yeah, it's just.
I
once.
think I'm on the wrong question, to be honest. Are we on E or are we on F?
We are on F, I think.
Oh, then I
You're
was
on-
not on.
We were no, sorry. I think we are on E. F is
Oh,
the.
okay.
Let me
Oh,
open.
yeah, okay. Then I was talking. Yeah, I was talking about F. My bad.
We are on E. Actually, we are on E. Yeah. So E is kind of like in a two-part. One is alpha dropout, and to get the output, just to use the same output to the MC dropout. So that's very interesting to know, Gautam, that you can train on one dropout and then you can utilize a couple of them to see if you have any difference.
So because MC dropout, it's the only kind of dropout that you have in inference, right? So they are just trying the same model, but actually with applying the dropout for a different number of dropout values and then averaging the results. Whereas other types of dropout, you don't even have them in the inference time.
Yeah. So in a sense, the MC dropouts, it's a very good point made by you. So MC dropout more use only on inference time, not what I was trying to do there.
Yeah, I mean, my knowledge is quite limited in this thing, but I think there is no difference between MC dropout and normal dropout during training time.
Training.
MC dropout is just when you additionally do it in the testing time as well.
Yeah, that makes sense. However, when we say here, he says sample in a range of n sample. So when we are doing inference, we passed X. What is the sample like? Is it?
I don't think it's badly named. It's just the number of different dropout values for which you want to do the inference. So what I think is he will predict on X by using 10 different dropout values, and then he'll average. So every time you run MC model dot predict, every time a different dropout value is initialized. Yeah.
But what value it's going to take? Like, so we are not saying anything.
Yeah, that's why it's random. It's random every time. Yeah.
Yeah. So this is where we called, and then we never say, okay, so it's just going to random drop out. Just take any value.
Yeah.
Yeah.
And yeah, all 10 predictions will be different because of the different dropout values.
Dropout value. Yeah. Makes sense. Yeah.
Then you average them.
Yeah. Cool. Yeah. Good. Okay. Yeah. So let's move on to the next one. Thanks for that. So the next one is retrain your model using one cycle scheduling and see if it improves training speed and model accuracy. Okay. And let's spend it. We still have 15, 17 minutes on it. So let's run this individually and see how we get on. I'm not sure whether it's going to work for me.
So where is this find learning rate function from?
So there are two functions which you need to run. One is one schedule running, and another one is on a top. If you go up your where is that? Yeah. So just search it up. It's up somewhere defined, and yeah, 34 cycle, 34 cell.
It looks like he's inspired a lot from FastAI in this one, right?
Correct. Yeah. I guess they follow each other, and then I think the as FastAI guy Jeremy, he's quite a big fan of Leslie Smith. So
Yeah.
but interestingly, I wasn't aware of this MC dropout or a alpha dropout before doing this exercise. So every time you do something, you learn something new. And I'm sure I read it when I read it, but coming back to exercise, it opens your eyes one more time. Okay, let's see. Yeah, so well, the accuracy has gone up to 52%, and epochs, I think it does only 15 epochs. So one cycle allows us to train a model in just 15 epochs, each taking only 3 seconds. Mine is 6 or 7 seconds. Thanks to larger batch size, this is over 3 times faster than the fastest model we trained so far. Moreover, we improved the model performance from 50.8 to 52. The batch normalization model reaches a slightly better performance, but it's much slower to train. Okay, have you done the training? Let's go back and then ponder on what he has done. So here he has just redefined the whole model. 20 layers, dense layer with 100 neurons, CellU as an activation. He's using alpha dropout, and learning rate is LE -3. And in here, he is using this finding learning rate. Finding learning rate, let's go back and then see if we can figure something quickly, which is defined here. So it's going to take a model, X and Y, epoch, and batch size of 32, minimum rate of 10 raised to power -5, and maximum rate of 10. Initializing weight. Okay, initial weights, get the model weights. The iterations length of X divided by batch size and a number of epochs. So how many times are we gonna go? Factor is, I'm assuming this is like what factor you're gonna move np dot exponential of this. Okay, I have no clue. Sorry about that. I need to read through it to make a sense of it.
What it looks like is for one epoch. So inside one epoch, after each batch, you increase your learning rate from min rate to max rate. So that's what the callback does. So you can see on batch end in the above callback exponential learning rate. So on batch end, yeah. So you can see the function def on batch end. So after each batch, the learning rate gets multiplied by the factor model.optimizer.lr times self.factor. So yeah, your learning rate is gradually increased for each batch inside the epoch, and then you get that nice plot of at this particular learning rate, this was the loss. At this particular learning rate, this was a loss. And then I think in FastAI, if you remember, we used to look at the steepest.
Yeah.
Yeah. So I'm not sure what happens in this case.
Yeah. So in a sense, you're saying learning rate keep on changing after every epoch?
No, after each batch. We are just doing one epoch. So the idea is to see at which learning rate do we see the steepest decline in the loss.
Okay, so we're going to do just one epoch for a whole, one epoch altogether in a learning rate.
One epoch, yeah.
And then, but we keep on changing the learning rate after every batch.
Yes.
Okay. Okay. Yeah, makes sense. Yeah. And then his idea was, I think it's Jeremy's idea. Well, everybody has their own idea. I think the so Sylvain, he has something similar, but Jeremy used to look at the like steepest, and whatever the steepest he gets, and he goes 10 10 times back and take that. For example, if this is steepest, it's going to go somewhere here to say, okay, that's my starting learning rate. But this is not the final learning rate. So he probably tweak after a bit, but that's a good start to. So that's the one cycle learning rate. And then what he's doing from here is he's actually, so this function is returning. Oh, so no, sorry, I misspoke. So find learning rate is this graph. So we define the model again. It's the same model. And now one cycle. One cycle would be the learning rate, would it? So what one cycle is doing? So length of scale, beside this blah. Where we are using one cycle, by the way.
That's another callback.
Okay, so let's go back to this. What's this one cycle is getting used? Okay, that's the callback, yeah. And so this is a set incorporate on batch begin of every batch. So when we say one batch this and then pass the values, which function you think going to go? So this callback will get called automatically on batch.
Yeah.
On batch begin.
Yeah, that's
automatically. So
yes.
if I go back to that's our program. So we said epoch this, and then we called it, okay, with these values, and then we have one cycle, and then when we fit, this callback is getting called here. Okay, yeah. So what this one cycle scheduler is sending or fetching, which we need to go and figure. Do you have any idea? No.
Yeah, I would have to see that on batch begin function and then try
Yeah.
to understand. So
So
that's
this
the function that gets called as like before starting each batch.
Yeah. Self dot interpolate.
So if you see the max rate, right, 0.05. So the initialization of the one cycle scheduler, one cycle equal to in the 100 cell.
Yeah.
You can see the max rate equal to 0.05.
Yeah.
So I think could that be the value he got from the graph?
From here.
Yeah. So so that's 5 times 10 to the minus 2, right?
10 to the minus 2. Yeah. So it's somewhere, probably somewhere here, or somewhere here, because it's a logarithmic value as per.
Yeah.
Yeah.
And then he uses, I think, so that value becomes the max of your learning rate. And then yeah, that is the max your learning rate can go up to.
Yeah.
And then I think it has that cycle
Yeah. And then
where it
it's
starts from a low value to that max value. Yeah.
starting from here. Start rate, maybe. What's the start rate? Is this the start rate? Not sure, but otherwise it's like -10, as you were saying 10 time before. Yeah.
Yeah. So that's the number of steps.
Hmm.
Yeah, length of X train divided by batch size will give you number of batches in one epoch, right?
Yeah.
And then you times it, multiply that by number of epochs, you get the total number of batches in your entire training process.
Correct.
So that's the number of iterations. So if you see the init function, the first argument is iterations.
Yeah.
So yeah, so that tells you how many times you have to modify your learning rate.
Correct. Yes.
And then max rate is what we got from the graph.
Okay. So all in all, when we are training a model, it's keep on changing. One cycle keep on changing the learning rate as we
Yeah.
go along. It's going to dynamically change the learning
For
rate.
each batch. Yeah.
Okay. Yeah. Okay. Yeah. At least. Yeah. Then probably I think that this whole bit is just to have understanding. Yeah. Oh, so the one cycle is more to do with just the graphing it. So it's not getting used anywhere. It's just to see what's going on. However, this one cycle schedule is giving you that maximum value, and then you just go 10 steps before and then start feeding that into your training model when you're training. Why the callbacks? Yeah.
Yeah. The initial graph gives you the max rate.
Yeah. 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 Yeah.
And
Oh,
then,
yeah. So you just take from here and feed in here. Yeah.
yeah.
Cool. Yeah. Yeah. Well, thanks for that. Actually, that makes sense. So it's, I'm like, wait, sorry. Yeah. So is this the one we were training? We were training down below here. Here. So that's why I was just confused. So yeah, we are using here. So max learning rate is we picked here and train with it. All right. Okay, that's good. We through this chapter. I enjoyed running these guys. I still have to figure it out, that MC dropout bit, but the rest is fine. All right, we are on time. Anything else you guys want to discuss? All right, if not, then we end here. So let's meet on next Monday to go over the chapter 12 exercise. I think there are a few exercise and a few theoretical question. 12th is the proper exercise question. Yeah, okay. We may take maybe a week or two to do it. That's good. Thank you very much. Anything else you want to discuss, or shall we finish it off?
All good. Thank you both. Bye.
All right. Thanks very much.
Thank you.
Thank you.